Okay, so this will be the volumes of solids of revolution. And it is we're going to cover disk method and washer method. But the main topic is we're switching from area to volume. So it's volume of solids. If you want to look at any neat ones, if you type in volumes of solids of revolution, and then I always add a couple of keywords when I'm searching. I search for applet, which makes it interactive, or I search on these. I search for volumes of solids of revolution, and search for animation or movie. Then you get something. Okay. Okay. And this will be we're going to look at disk method, and we're going to do the disk method first, and then we're going to look at the washer method. Okay. This first part, I'm not going to make you write all this down, but basically on the disk method, we're going to consider a region between the graph of a continuous function, y equals f of x, and we're going to look at bound it by the x-axis from x equals a to b. Okay, and the volume of the solid generated by revolving that region about the x-axis. If you revolve it about the x-axis, the volume equals the definite integral of pi times the radius squared with respect to x from a to b. Okay, and the radius, and basically I would probably take that pi out front because it's a constant. The radius is going to be our f of x. That is going to be like the radius of our circle or our disk. And area of any circle is pi r squared. So that f of x is like our radius, and it's squared with respect to x. Okay. Now we're going to look at an example of a football first. You don't have to write all this down. Okay. For the volume, I'll just put it as an example. The volume of a football. Okay. Back in 1905, President Theodore Roosevelt requested the formation of the NCAA, and then with the introduction of the forward pass in 1906, gives you a little history. The shape of the ball was altered to make it easier to grip. The regulation size football had a length of 11 to 11.25 inches. And the girth, remember that's the distance around, was 21.25 to 21.5, and that was in inches. Okay. If you take this equation, and we're going to revolve the graph of f of x equals a negative 0.0944 x squared plus 3.4 about the x-axis, and our x is going to be less than or equal to 5.5 and greater than or equal to negative 5.5. Okay, now I'm going to give you a window. If you were doing this on your own, you would experiment with it until you get it to show up in a good window. I'm picking the window for you. For x, let's go negative 6 to 6, scale 1. For y, let's go negative 5 to 5, scale 1. Okay, so first let's graph that and get a good window. So clear out any equations and put in negative 0.0944 x squared plus 3.4. Change your window. X min's negative 6 to 6, scale 1. Y min's negative 5 to 5, scale 1. Okay. So you should see, and draw a sketch of that on your paper. You should see something like this. And now we're going to rotate it. Most of the time they're only going to give you part of the graph. You have to visualize the symmetry. If I do the symmetry and rotate that about the x-axis, they will tell you x or y. If we rotate that about the x-axis, you get something that looks like that. Okay? Now, if I take a slice, okay, think of this as like a, I don't know, cucumber or something, something looks like that. Huh? What would be good? Something like that. If I slice it, okay, down this way. So if I slice that this way and take a slice out of it, if I turn that slice so that you could see it, you're actually looking at this, right? And it would be a solid slice, show that, right? So you'd be looking at something like that. What's controlling this radius? What's controlling that radius is that curve, right? Okay. Okay, so figure the volume equals, okay, the integral of, and we're going to put the pi, let's put the pi out front, and times f of x, and it's that thing squared with respect to x. So sub in, our pi is going to go on the outside, and then they gave us the equation, negative 0.0944 x squared plus 3.4. Now this is the most common error, is people forget this. That has to be on the outside, squared. We have to square because we're using the formula for the area of a circle. What's the formula for the area of any circle? Pi r squared. But what's controlling our radius is that y value. And then we're going to extend that all, we're going to take slices all the way down and extend it from negative 5.5 to 5.5. Okay? Okay. Next part. When you first graph it to get the picture. Okay, and that's fine. Now, we're going to do all this on the calculator. Now you got to do this part with it squared. And you're going to have to adjust your window, because this window isn't going to cut it. So, okay, so now go back. You got to insert a parentheses. Okay, insert a parentheses there. Go all the way to end, parentheses, and then square it. Okay. Now you can go ahead and say graph. It will start graphing it, but you should see something. And this has nothing to do with the actual. This is just, okay. You're going to see something like that, right? Okay. Do zoom 0. Remember zoom fit, or you can put the trace key on and see how high up it goes. If I do zoom 0, okay, it should kind of regraph it. Okay. So you see something like that. Okay. Now what we need to figure out, and we're going to let the calculator do it, is we're going to do the integral. We need to find the area underneath that curve, and we're going to do it on the calculator. So do second function calculate, and it's number 7. Okay. Now for the lower limit, okay, we were going for, oh, I left those off. Hang on. I left those off. We were going from negative 5.5 to 5.5. That's what, and they gave that to us in the directions. Okay, so type in negative 5.5 for the lower limit, press enter. For the upper limit, 5.5, press enter. $73.9. So put another equal sign. So hang on. We actually figured it's pi. And now we figured this part inside is 73.900. Go 3 decimal places when you write it down. Now, don't do anything else, just hit times pi. Use your pi key above the caret symbol. Okay? And your volume is 232.164, and that's in cubic inches, or inches cubed. Okay, and that would be the, so you're figuring that area of the circle. That's the 73.9 times pi, and then when you figure the you figured the negative 5.5 to 5, that's actually extending it out so you get the volume. Okay? Okay, let me stop there. Okay, we just did one where we rotated it about the x-axis. Okay? And that, now I'm going to give you the other formula. This is the volume of a solid rotated about the y-axis. And this is still disk method. You're not going to get a hole in the center. It's just they're always going to come out a solid disk. Okay, and the volume is, I would still put that pi out front. Okay, that's another common error is people forget to multiply by pi. Okay, so it's the integral pi times the integral of the radius. It's still the radius squared because you're taking the area of a circle. But this time it's with respect to y, and we're going to go from c to d, and that means you're going to use the y values. So pi times the integral, and it will be f of y quantity squared with respect to y from c to d. Okay. Okay, now we're going to stop and we're going to add. You need to say like volume, disk method. Okay, and I would say about an x-axis. This one up here, the first one that I gave you, you might want to add to that. This is about the x-axis, rotated about the x-axis, and it is the disk method. I need you to put that one, and I need you to put this last one. That one's about, they're both disk method, and that one's about the y-axis. Okay, we're going to take a minute. Okay, we've added those formulas to the card. Now, this, we're going back to Borg, the turtle problem. Okay, this, it says Christmas and New Year's Day have come and gone, and now it's time for Borg to clean up. Wrapping paper, bows, ribbons, and confetti are strewn across his house, and now he must put it in the trash bag to throw it out. The bags Borg is using can hold a volume equal to the volume of the solid generated by rotating the graph bounded by, okay, so it's bounded by y equals 0. What kind of line is that? Horizontal, right? And y equals, and they give you the equation negative, the quantity x minus 3 quantity squared plus 5, and you're going to rotate that about the x-axis, and the volume is in cubic feet. Number one, what is the greatest volume Borg can put into each bag? If the volume of Borg's trash is 50 cubic feet, will one bag hold it all? Okay, so we're going to go through this problem. You can either write it in your notes or put it on the back. Probably write it in your notes, that way you can still look at it. Okay, so on number one, okay, first you need to clear out the equations, and we're going to graph. Okay, in y sub 1, we're going to put in negative x minus 3 quantity squared plus 5. We know that's a parabola, y to the first and an x squared, and it's negative, so we know it's going to be a parabola that opens down. Okay, so let's graph that, and we need a good window. And probably do zoom 6 to start. Let's see. Okay, that's good enough. So we've got, and do a little sketch of that. It does not go through the origin. Okay. Now the only part that we really need is we're looking at this, because it's bounded by that curve. It's bounded by this line, y equals 0, and then we're going to rotate it about the x-axis. So if we rotate this about the x-axis, we're going to end up with this bag looks something like that. Okay? And now, if I take slices of it, okay, if I take a slice of that and then look at it, it's actually like a circle. What's controlling this radius of my circle is from here to here. What's controlling that is this outside curve. Okay? So I need the area of the circle, pi r squared. So when we're looking, we do need to figure, let's do that first. We need to figure these x values. To do that, okay, we've intersected it. So let's do second function calculate. And let's do 0, right? Okay. So go ahead and do that. Do second function calculate. Figure the x values. Did you get something like 0.7639? 3202? And it'd be up 0. And this one I got like 5.236068 and up 0. Okay. And we're integrating with respect to x. Okay, so we're going to use the x values. So mark the x values on your paper. Okay, so now figure. We want the volume equals pi times the integral of f of x, and it's that quantity squared. When you're figuring that, you're figuring pi r squared. That's the area of the circle, okay? And then we're going from A to B. So figure pi times the definite integral. We want that formula, so it's negative. I didn't draw that very good. It's negative, and then x minus 3 quantity squared plus 5, and then it's with respect to x, and we're going from 0.763902. Notice I'm not rounding this until the final answer. 5.2360, and we're not doing it algebraically. We're doing it all using the second function calculate integral. Okay. Okay, so now we've got to go back to our original. We've got to insert parentheses around it. So do second function insert, put parentheses around the 5, and square it. Yep, okay, good. I forgot the squared, so you need to put the squared there. Sorry, that's my fault. Okay, and then, see, it was a common error. Okay, then this is when you graph this, you got to adjust the window. Zoom 0. I would just do zoom 0 is zoom fit. It will always give you a window. May not be the best, but okay. And I want to do second function. Oh, wait a minute. Did I do it on that? Yeah. Do you agree with my graph?
Yeah.
Okay. Let's do second function calculate. And it will tell us if we don't have a window in the right. Okay. Lower bound, put in 0.76393202 for the lower. For the upper limit, put in 5.236068. Okay, and I got 59 now. It's not really showing me a picture. If I want the picture of that, I would have to change my window. But it gave me what I want. Okay, so pi times 59.6285. Don't clear it on your calculator, just hit times. Times, that's the advantage. Okay, and then times pi. Okay, so the area, not area, volume, sorry, volume is 187. Now go 3 decimal places. This is where you round it. 328, and that would be in cubic feet or feet cubed. Okay, so now you go back and answer the question. If he had 50 cubic feet of trash, is it going to fit in that bag? Yes. So that answers yes. 50 cubic feet will fit. Okay? Any questions on that one before I go on? Okay, the next one. Okay, it says after all his cleaning is done, Borg is hungry, and so he starts to eat a glazed chocolate donut. Okay, a traditional furry turtle favorite. The volume of the donut in cubic centimeters is, ooh, this wasn't cubic, hang on. Oh, no, they switched. Cubic feet to cubic centimeters. Okay, now we're in cubic centimeters for the donut. It's equivalent to the volume of the solid generated by rotating the graph bounded by the line y equals 3, so it's bounded by a horizontal line, and by the equation y equals negative 3 times the quantity x minus 3 to the 4th power plus 7. Now, what are they rotating it around? They're rotating it around the line y equals 1. They are not rotating it around the x-axis. Okay, so that throws in a little bit more. Okay? Okay, so first they want us to find the volume of the donut. Okay? So, clear out this one. Okay, we need to graph the negative 3 and then parentheses x minus 3, okay, to the 4th power, okay, and then plus 7. Okay, and I'm going to do zoom 6 to start. Okay, and then graph y, in y sub 2, let's graph y equals 3. Okay, and then in y sub 3, let's graph y equals 1. Okay. So, picture-wise, okay, draw a little sketch. We are basically going to take, here's at y equals 3. And y equals 1. And then we've got something like this. Okay? Now, we are going to rotate that. And when we rotate it, what's it going to look like? Okay, so if this is distance from here to here is 2. So from here to here, there's got to be another one down here, right? Do you agree with something like that? Yes? Okay. Now, if I rotate that, it's going to look like a donut. Okay. The inner part. Okay. Okay. That's controlling the hole in the center. Okay. So when you take a slice of that donut, if I cut down here, okay, it's going to still end up, from the side view, it's going to look like this. Okay. There's going to be an inner radius and there's going to be an outer radius. Okay. Okay. Okay, before we get back to this, I want to go through the two formulas, and we're going to add the Warscher formulas to your card. Okay, so this will be let's do volumes of solids, still of revolution, and this is going to be the two formulas for the Warscher method. And like I said, I'm going to leave the shell method to Calc 2. Okay, one is about the x-axis and one's about the y-axis. So the first one is volume, and the pi is still the constant, because we're still taking the area of a Warscher, each circle. Okay. So on this one, it's the pi times the definite integral. Now it's the outer radius. Okay, so and that outer radius is our uppercase R squared of x minus the inner radius is the lowercase r squared of x. Okay, and then it's that whole thing with respect to x. Okay, and it's from A to B. And we've already squared them inside. Okay, and this label that is about, we're rotating this one about the x, this revolved about the x-axis. Okay, and then the one about the y-axis is the volume. Still got pi, the definite interval, and it's uppercase. It's still the outer radius. Uppercase r squared of y minus lowercase r squared of y. And then it's with respect to y from C to D. And these would be the y values, from the bottom y value to the top y value. Okay, and this one is revolved about the y-axis. Okay, now add those to your... Okay, so now we're going to go back and finish this donut problem. If you took a little slice right through here, okay, what we need to talk about is what's the inside radius. Okay, the inside radius would be this, it would look like this, and the radius goes from here to here, from 3 to 1. So the inside radius is 2. What's controlling the outside radius? The outside radius would actually go from here to here. What's controlling that radius? It's that outside curve, but did it start at the x-axis? It actually started at 1, so I have to subtract 1. Okay, so here's what your formula is going to look like. And we're rotating it about the x-axis, so we're using this part, we're using this, right? So we're going to do the volume is pi times the outer radius, that's uppercase x squared, minus lowercase r squared of x, that's the inner radius, with respect to x, from, we don't know what from, so it's from the x value on the left to the x value on the right. So I need to figure out, now I have this graphed and I have the y equals 3 graph, so instead of using second function calculate 0, I'm going to use second function calculate intersect. Okay, so you need to take a minute and figure out what those two, I know the y value is 3 on both of them. I want to know what's the x, because we're integrating with respect to x, we need to use the x values. Okay, take a minute, calculate that. Yep, 1.9254,301, and it would be 3, up 3. And then this x value, I got 4.0745699.3. Okay, so highlight what we really want is we want the x values. Okay, so we're going from A to B. So now when I sub in my formula, volume equals pi, and the integral, my outer radius is controlled by the -3. And then, let me change that. Let me make that a brace so that'll look better. It's -3 x minus 3 to the 4th power plus 7. And then we had to subtract 1 because it didn't start at the x-axis. So subtract 1, and we're going to square that. That is our uppercase r of x squared. Minus, we said the inside radius was from 1 to 3, so the inside radius is 2 squared. And it's that whole thing with respect to x from 1.9254,301 to 4.0745699. Okay? So, now we got to go back in. Okay, I would clear out the y sub 2 and the y sub 3. We need this whole thing squared, so insert a parentheses. We need this one, and we need to put a -1 on there at the end, right? -1 quantity squared, and then -4, right? Or -2 squared. You agree with that? Okay. Do zoom 0. And you don't really have to graph this next part. You just need it for your calculation. Okay. Do second function calculate. Number 7. Our lower limit is 1.92543301. My upper limit, I have 4.0745699. I get pi times 51.9614. Okay, then hit the time sign, and then pi. So the volume is 163 point, now here's where you round it, 242, and this is in cubic centimeters. Okay, so cubic centimeters. Okay, so now we go back to their question. What did they ask? What is the volume? Okay, we've got that, 163.24. Okay, if board can eat 120 cubic centimeters, will he be able to eat the entire donut? No, because it's too big. The donut's too big. Okay? Okay? Okay?